chosen the career of a toxicologist, so let's
Yes.
explore what a toxicologist does.
Okay.
Okay, so we're in the toxicology lab. Looks like that tablet's blinking, so let's see what it's about. So we've received an email, and it's looks like you're a trainee here, so you're a new toxicologist. You're getting ready. So hello, trainee. We need your help in running some toxicology tests. A young male was killed in a traffic accident. We have already ruled out alcohol. I have started the ELISA test to screen for drugs, but had an emergency. I need you to finish up for me. And it's from Parker Jacobs, the forensic toxicologist. So we're going to be testing to see if there was any drugs involved in this crash.
Okay.
So it looks like those lab materials are blinking.
Yes.
Okay, so the ELISA test is used to screen for certain types of drugs in the victim sample. First, the blood must be diluted. So use the pipette to transfer the victim's blood to the buffer solution. So good. Got some of the blood.
So
Drag the sample and place it on the top of the vortex mixer to mix it. So we're going to mix it all up. Okay, so the controls have already been added to the plate. So you can click on the positive and negative control. So let's see what this is about with these positive and negative controls. Positive control is a sample that purposely contains the drug. And a negative control is a sample that purposely does not contain the drug. So Tomer, why do you think we have these controls when conducting these experiments?
They let us know to distinguish which they're just to distinguish how to the difference, the difference of positive and negative.
Exactly. So we know exactly what a positive test of that certain drug looks like and what a negative test of that one looks like. Good.
Yes.
So let's conduct the experiment now. So why are the controls needed? Oh, we just kind of went over that. So is it to increase the chances of the test being correct, to give more practice to interpreting the results, or to show what a positive and negative result should look like? Which one do you choose?
I think it'll be the third one.
Okay. So very good. So it's going to show what they look like and make sure the test works properly. Okay, so use the pipette to add the diluted blood sample to the plate. Good, so we're testing for a lot of different drugs that man may have taken. So use a pipette to add the reagent to the ELISA plate. So it says up here that a reagent is added and it will change color when the drug is detected. So compare the blood sample with the positive and negative controls. Were there any drugs in the victim's system? Remember that the solution only turns blue if the drugs are present. So let's see, did any of them turn blue?
Yes, it did.
Which one?
This row of drugs, or this.
Oh, this one here?
This drug right here.
Okay, good. So it looks like it's for methamphetamines.
Oh.
So which one do you choose?
I would say the victim had methamphetamines and amphetamines in his system.
Very good. Very good, you're correct. Okay, can you tell if the amphetamine or methamphetamine was in the blood sample? So does it tell you which one is there?
Both of them are there.
Yeah, it doesn't really distinguish between the two. So can you tell?
No.
No, so that's our last one right there. Okay, good. So we have to do another test to see exactly what drug it is. Okay, so it looks like that's blinking now. Let's see what else we're going to test for. Let's see, drag syringe 2 CMMS.
Wait, right here? Oh.
Here. Yeah, it doesn't kind of tell you how. How about this in the front? Okay.
Yes.
So this is a gas chromatograph mass spectrometer, and it can be used to confirm specific drugs that are in the victim system. So this is going to be more specific.
Oh, okay.
So it separates the chemicals in a specimen and then identifies each one. So let's click and see how it works. Let's announce analyzing. The chemicals in the sample separate from each other based on the difference in properties. So why do you think we don't go straight to this machine first when we're testing for those drugs?
Because that's a further more detail of what it is, and the other test is just to tell like what's
The general categories,
yeah, the general.
right? Okay, good. Let's click next. Yeah, so this one might be more time consuming or it could be more expensive. So the ion source, the chemical gets a positive charge and breaks it into fragments. So it's telling you how the machine works. It's breaking it down. Okay. So the analyzer sorts the fragments of each chemical by similar properties, so it's categorizing it. So it does look like this is a very specific test.
Yes.
The detector adds up the number of chemical fragments of each type. The graph of this data, called a mass spectrum, is generated for each chemical found in the specimen. So it looks like there's a few chemicals there. So let's see, I'll probably pull up the graph first. So I'll roll over the labels to learn more. So it's showing you that the mass spectrum is a graph created by the mass spectrometer of a specific chemical. The plural of mass spectrum is a mass spectrum. So it's just saying the different types of chemicals that might be there. Okay. I think there's a few more words. How about the peaks? So the peaks, each fragment of a chemical appears as a separate peak. Each chemical has its own specific patterns of peaks. So we're seeing some peaks, right, of different chemicals. So let's click out of here and maybe it'll help us analyze which ones are there. Each specific chemical has its own specific mass spectrum, like a fingerprint or snowflake. It is unique. Now we're ready to analyze the car crash victim's blood. So let's analyze it and see what those peaks mean. Click on the arrows to tab through the small graph on the right. When you find a graph that matches the big graph on the left, drag and drop to the small graph onto the big graph. So we're going to look at this graph and this and see which one matches. So we're looking for one that matches it.
No, it doesn't match.
Okay, so we're going to click here. How about that one?
Not really.
Okay.
No. Yes, this one matches.
Okay, so you're going to drag that graph onto the larger one. There's your match. So they found caffeine. So is caffeine legal or illegal?
Maybe you won't.
Yeah, so that's not something we're going to be looking for.
Oh, okay.
So I think we can click beyond. You found caffeine in the victim's blood. However, caffeine is not in the class of drugs that we're looking for, and it couldn't impair his driving. Keep looking. So,
This graph is
that's kind of similar, right?
no.
Okay, let's get another one. caffeine drug that we found last time, the caffeine graph.
Touch it this one. Well, yes, this one does
Okay.
take it.
Oh, so what did you find?
It says meth, cathone, no.
Found, okay, good. So we found that drug, so good job. Methacathinone, a cat, is a type of methamphetamine that acts as both a stimulant and as an hallucinogen. This must have impaired his driving. So not only was his body stimulated, but he was hallucinating too as he was driving. So, of course, he's going to crash. Okay, so click out.
Oh.
We have a new message. So
Victim's
let's just-
crash report. Crash victim report results.
So we're gonna check on the chemical present in the victim's blood. So what did we find?
Meth. This one right here.
Very good. So you can click it.
And the board. Sexology. What is it?
So, let's look if it's for you. So that's what we're trying to find out if you want to go into this career. So if you have patience and an eye for detail, are practical and methodological, and like to work with tools and machines. So, so you don't time?